Connection established.
In this tutorial, we will discuss the insertion sort including its concept and examples. We will also implement Java programs to sort an array. So first, what is insertion sort? Insertion sort is a simple sorting algorithm that allows for efficient in-place sorting of the array one element at a time. By in-place sorting, we mean that the original array is modified and no temporary structures are needed. The insertion sort algorithm technique is similar to bubble sort but is slightly more efficient. Insertion is more feasible and effective when a small number of elements is involved. When the dataset is larger, it will take more time to sort the data. So, the larger the dataset is, the highest the time to consume. Insertion sort is useful especially in sorting linked list data structures. As you know, linked lists have pointers pointing to its next element and previous element. So for example, we have here an already sorted array. So we have an index 0 which is 2 in index 1, we have 3 in index 2, we have 7 in index 3, we have 8 in index 4, we have 10 in index 5, we have 13. So remember that when we talk about index, it starts with 0 and then element starts at 1. So expected, what if we insert number 5? Number 5. So expected that this number 5 will insert at index 2 because we talk about insertion means arranging the numbers through decrease to increase. So here's what happened when we inserted number 5 in this array elements. So we can see that number 5, which is the inserted number, is at index 2, swapping at the number in index 3, which is 7, because 5 is less than 7.
Good day everyone. So after Alma explained her tasks about insertion sort, so we have also created this implementation Java, which is class who. So after that, we create the method or the insertion sort, and as you can observe here, we also have the for loop starting at index I equals 1. So ARR.length give us the number that the array contained. So inside the for loop, so the for loop defines the index j with I at the beginning. So and with this index, we can have our inner loop or the while loop with its own condition. So to make it easier for us, we can also make a temporary variable. So makikita niyo dyan, diba? That holds the array at index j after assigning. So at last, we need to store the temp variable at position j minus 1. So again, there we successfully swap the element j with element j minus 1. So then we need to go left. So we have to go to decrease at index j. So since we define our method to return the solve array, so we also don't forget to include the the return statement at the end part. So meaning para hindi na paulit-ulit yung ating pagbasa ng program sa ating codes. So after that, we have also the main method. So and below that one is to define our exemplary form area and to call the method of the array. So makita nyo dyan ba, meron tayong mga values at mga indexes. So we have to also to print or to print our values kung it's really working ba or hindi. So let's check this out. So to test out the correctness and effectiveness of our implementation code, so the output is 1, 5, 9, 30, 50, and 57 and 90. So to test out again, so if we need to change if it is really effective ba or hindi. So kung i-change natin yung values ng ating mga indexes, so same pa rin. Since we are using the insertion sort array, so masasort talaga siya, meaning maka-in order siya into descending to ascending order.
Bubble sort algorithm. A bubble sort algorithm repeatedly swaps adjacent elements if they are in the wrong order. The bubble sort is often used to implement a sorting algorithm. Every element in the bubble is concentrated with its surrounding elements in bubble form. How bubble sort algorithm works. If you are the one who focus on names, then you might have got an idea how bubble sort works. Just like a bubble comes up from water. In bubble sort, smallest or largest number depending upon whether you are sorting array on ascending or descending order. Bubbles up towards start or end of the array. We need at least in pass to sort the array completely, and at the end of each pass, one elements are sorted in its proper position. You can take first element from an array and start comparing it with another element, swapping where it's lesser than the number you are comparing. It is said that a picture is worth more than 1,000 words, and it's particularly true in case or understanding sorting algorithm. Let's see a step-by-step example to sort array using bubble sort. Give an array of items. Sort them in increasing order. For our examples, we just use sample sort list of integers. So we have 6 items in our unsorted list of integers. We're going to number them 5, 1, 6, 2, 4, or 3. In this array, we start from index 0, which is 5, and starts comparing elements from start to end. So, first element, we compare 5 is to 1. And since 5 is greater than 1, we swap them because ascending orders sorted array will have a largest number towards end. Next, we compare 5 to 6. Here, no swapping because 6 is greater than 5 and it's on higher index than 5. Now, we compare 6 to 2. So 6 is greater than 2, true. So swap the 2 move to the left and the 6 move to the right. Next, we are compare 6 to 4 and 6 is greater than 4. So to swap the 4 move to the left and the 6 is moved to the right.
Now, we compare 6 to 3. 6 is greater than 3, which is yes. So swap the 2 items. 3 move to the left and the 6 is moved to the right. Here we can see the array after the first iteration. Similarly, after other consecutive iterations, this array will get sorted. After one iteration, this is what our list looks like. Now, if you compare that to the original list, you can see that after one iteration, indicating that the smallest items move all the way to the left. One thing is for sure, however, the largest item does move all the way to the right. It bubbles all the way to the right, and in this case, it is item number 6 and 1, which is in the sorted part of the list. So let's look the next iteration. So we'll leave 1 and 6 because it's already been sorted. We're only going to look index 1 to 4, the second iteration, which is 5 to 2. 5 is greater than 2, so true. So swap the 2 items. The 2 move to the left and 5 move to the right. Next comparison is 5 to 4. 5 is greater than 4, true. So swap the two items, 4 move to the left and 5 move to the right. Next is 5 to 3. 5 is greater than 3. True. So swap. 3 move to the left and 5 move to the right. That completes our second iterations of the bubble sort. We can see now that two rightmost items, which is 5 and 6, are completely sorted. The rest of the list is only partially sorted. The one has worked its way all the way into the leftmost position. But some of the other items are not going to correct all order, so after two iterations, we have two items on the rightmost end of the list that are completely sorted. Okay, for the third iterations, compared 4 to 3 are unsorted. So 4 is greater than 3, which is true. So swap the two items, and 3 move to the left and right, and 4 is moved to the right. As we can see, the list completely sorted. So let's look at the big zero analysis. Due to the use of nested loops, similarly to the insertion sort, the bubble sort is not a particularly efficient sorting algorithm. It runs slower than certain merge sort and other sources. Therefore, it is only useful for relatively small data sets. Therefore, code up the bubble sort in Java because it has a big O and N squared running time. Use I for the outer loop variable and J for the inner loop variable. After two iterations, I have the following data sets. Justify how far we want J to go. We really only need J to go from 0 to 2 because we'll be comparing J and J. So we have bubble sort code sample. The program shows that the Java implementation of the bubble sort algorithm. Here we maintain an array of numbers and use two for loops to traverse through adjacent elements of the array. If two adjacent elements are not in order, then they are swapped. Okay, we have example of bubble sort. So we have example of the bubble sort. Import java.util.asterisk class main. We have this is the driver method to the test above. Public static void main string args, and we declare an array of integers. So int array and close and open bracket. Then we have value. So nag-declare taog ay we are declaring value. So to have 23, 43, 13, 65, 11, 62, 76, 83, 9, 71, 8, 4, 34, 96, and 80. So we print the original array, system.out.print ln, print the original array plus arrays to string int array. Then int n equals to int array that length. So the iterate over the array comparing adjacent elements. So we're going to have use for loop int for int I equals to 0, I and lt, then n minus 1, then I plus plus, then 4, another for loop int j equals to 0, j and lt, n minus I minus 1, then j plus plus. If elements not in order, swap them. So we're going to use if statement. Int array, open and close parentheses, open and close bracket, and gt. Int array, open and close bracket, square bracket, j plus 1, int temp equals to int array, open and close square bracket, j. Int array, open and close square bracket, j equals to int array, open and close square bracket, j plus 1, then semicolon. Int array, open and close square bracket, j plus 1 equals to temp. Then print the sorted array, then system.out.println sorted array plus the array to string int array. So the output is this.
Selection sort. The selection sort algorithm sorts an array by repeatedly finding the minimum elements or considering ascending order from the unsorted parts and putting at the beginning. The algorithm maintains two subarrays in a given array. The subarray which already started. Then the remaining subarray was unsorted. Given an array of items, sort them in increasing order. In this video, the items will simply be integers for simplicity's sake. So, how the selection sorts works, it sorts through the list to find the smallest item in the unsorted part of the list, and then moves that to the first positions in the list. So let's start with an unsorted list. We have 6 items. We're going to number them 0 to 5. So then we'll take a look at the first item. We're going to set our main value to 7, which is the first item. So far, we haven't found anything lower than 7. So we compare 7 to 8. So 8. Is 8 less than our main value of 7? No. Is 5 less than main value? Yes. So we'll assign 5 to the main value. There's 4 less than on main value. Yes. We'll assign to main value is 9 less than the main value. No. Is 2 less than the mean value? Yes. So we're done with our first iterations of the list. We found our smallest items. It's 2. We want to move that into the first position of the list, which is her. So we're going to swap the 7 into 2. Now we're going to be mark the 2 as already started. We know now at this point the 2 is the smallest item in the list, and it's in the first position. So it sorted. Our second iteration is going to start with the 8. So we're in set mean value equals to 8. Is 5 less than mean value? Yes. We set mean value to 5 is 4 less than mean value. So we set mean value to the 4 is 9 less than mean value. No. Is 7 less than mean value. Notes or smallest item in the remaining items in the list is 4. So we're going to swap the 4 with the first unsorted item, which is 8. So 8. Now the 4 we're going to mark is sorted, and the first items are smallest 2 items in the list. So we have 2 items that are sorted. The 2 and the 4 are the first smallest, and then the other 4 items are unsorted.
So our third iteration will start with 5. We set mean value equal to 5. We compare 8 to 5. Is 8 less than 5? No. Is 9 less than 5? No. Is 7 less than 5? No. So 5 is already in the correct position. We didn't know that until we iterated through the list compared to each item. Now we know that the 5 is in the correct position. We don't have to do any swapping. So while mark 5 is sorted, we move on the 8. Well, set our main value to 8 is 9 less than the mean value. No. Is 7 less than mean value? Yes, 7 is less than to 8. So we mark the mean value as 7. We'll swap the 7 with the 8. Now, we can mark the 7 as sorted and we have 2 remaining items. So we'll set mean value equal to 9. Well, compare the 9 to the 8 is 8 less than the mean value. Yes, it is. So we don't need to swap these last 2 items. So we'll do a swap. Now the list is fully sorted. So that is how the selection sort works. So let's now demonstrate the Java program to implement selection sort. Import java.util.asterisk semicolon class main close parenthesis static void cell underscore sort close and open parenthesis and num array bracket close parenthesis and n equals num array dot length semicolon for close and open parenthesis and I equals 0 semicolon I less than n minus 1 semicolon I plus plus close parenthesis and main underscore idx equals I semicolon. For int j equals I plus 1 semicolon j less than to n semicolon j plus plus close parenthesis. If num array bracket j is less than to num array bracket min underscore idx min underscore idx equals j semicolon and temp equals num array bracket min underscore idx semicolon num array bracket min underscore idx equals num array bracket I semicolon num array bracket I equals temp semicolon close parenthesis public static void main string args bracket and num array bracket equals 7 5 2 20 42 15 23 34 and 10 close and open parenthesis semicolon system out print line as original array plus arrays dot to string close and open parenthesis num array cell underscore sort num array system out print line sorted array plus array to string num array output original array 7 5 2 20 42 15 23 34 and 10 sorted array 2 5 7 10 15 20 23 24 and 42. Selection sort works by maintaining 2 sub-arrays. The minimum element from the unsorted sub-array is placed in its proper position in a sorted sub-array. Then the second lowest element is placed in its proper position. This way, the entire array is sorted by selecting a minimum element. During each iteration, int num array bracket is equals to we have 7, 5, 2, 20, 42, 15, 23, 34, and 10. System out print line original array, double quote, plus array, dot to string, num array, cell, underscore sort, of a num array. System out print line, sorted array, plus array, dot to string, num array, semicolon, and curly bracket.
Merge. What is merge sort? Merge sort is an efficient general purpose and comparison-based sorting algorithm to understand it widely. Let's observe this one. Observe this. So this is the problem, array problem. So we have 8, 10, 7, 1, 4, 45263. So after the merge sort algorithm, the output is this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's continue. Explanation. So in explanation, the array, the length of an array is 10. So let's divide it into half. Divide it into equal half. So the 10 divided by 2 is 5. So let's divide it into 2. So it is 5. So after that, divide it into equal size again. So we have 3 and 2. 3 and 2. So proceed it again. 2 and 1, then 1, 1. Divide it again. So we have this one. So we have divided into 1. So let's proceed applying the merge sort. Applying the merge sort. So we have this. Combine it or merge it. That's why it calls merge sort. So let's combine each pair. So 8 and 10. As we observe at the 7 and 1, the 1 is the first and the 7 is the last. So that we observe that in this merge sort, it is in order. Like this one, 9 and 2. So 2 and 9. Let's proceed. So we observe at 8, 10, 1, 7. The output is 1, 7, 8, and 10. So it is in order. Like in 4, 5, 2, 9, it is in order. And 3, 6. So let's proceed. Do that again in 2, 4, 5, 9, and 3, 6. We will merge it. So it is in order. 2, 3, 4, 5, 6, 9. And lastly, the 1, 2, 3, 4, 5, 6, 7 and 10. So this is the result. After that, this is the merge sort algorithm in Java. So as you can observe, this is the algorithm, which is very hard to explain. Then proceed it. That continues in the code. There are 89 lines of code, I think. So this one, and this one, this one, and this is the output. That's all, and thank you everyone.
Hello everyone, good day. I am Sofia T. Morado. Our topic for today is all about quicksort algorithm. Now, what is a quicksort algorithm? It's a sorting algorithm which is leveraging the divide and conquer principle. It has an average 0 and log n complexity, and it's one of the most used sorted algorithms, especially for big data volumes. It is important to remember that quicksort isn't a stable algorithm. In the quicksort algorithm is a special element called pivot. It's first selected and the array or list in questions is partitioned into two subsets. The partitioned subsets may or may not be equal in size. Given array of items, sort them in ascending order in this video. The items are integers. First, there are a couple of terms we need to understand before we can start. Using quicksort, the pivot is an item that is used to compare every other item in the list too. So we'll compare every item to 22. In this case, we will move all items that are smaller than the pivot to the left of the pivot and all items that are larger than the pivot to the right of the pivot. As you can see here, all items to the left right are larger than the pivot. Another terms is partitions, so that left side of the pivot we have the left partitions. On the right side of the pivot we have a right partitions. To pivot essentially partitions that array in two subs arrays. Now let's sort the items for this video. We will always choose the right items as the pivot, in this case 13. We will have our pivot and I've highlighted that in blue we're going to sort the items 0 to 7. Again, every comparison will be made only to the pivot. So, we're going to use pointers from the left and the right. The right end of the list, our first comparison will be 17 to 13. It is now we're going to jump over to the 3 is less than the pivot. So yes. It is so since 17 is larger than the pivot of pivot and 3 is less than the pivot, we know that we can swap the 3 with the 17. Now, we'll move both pointers in towards the center. We're going to start with 41 and larger than the pivot. So, yes, it is 29. Is less than the pivot. So no. So move to the pointers. Move to that pointer for an item that is smaller than the pivot. Is 6 than the pivot? Yes. So we can swap 41 and 6. You can see we're moving the larger items to the left and the larger items to the right. We'll move both pointers towards the center is 5. Now, 5 greater than the pivot. So, yes, it is now from right arrow. We're looking for an item that is less than the pivot is 54 than the pivot. So, no. Look to the two arrows have met in the middle. Now, at this point, we're done sorting using 13. So, 13 as our pivot. So, we're going to swap the 13 into place where the 22 is where the 2 index is made. So, now, we know that all items to the left of 13 are smaller than 13. That all items to the right of 13 are larger than 13. Larger than 13. Then, the 13 is in its correct position. The position number 3, now, we have a left partition and a right partition. Are we going to call quick sort on each of these two partitions? In turn, we'll start with the left partition. We have 3 items. There 0, 1, and 2. We're going to select the rightmost item as our pivot, which is 5. We use 2 pointers. We're going to compare 3 to 5 greater than the pivot. So, no, it is not. The 2 pointers have already met in the middle. So, at this point, we can swap HTHE 6 and the 5. Now, we can see that
Now the whole left side of the list is sorted, and we have 5 items on the right to sort. So we're going to choose a pivot at the rightmost item number 22. We have 4 items to compare against. So we'll start with 2 pointers, 1 at each end. So is number 54 greater than the pivot? Yes, it is. So
So let's take the sample code of quicksort. So we have here the import java.util and our class name, which is the quicksort. So here at the line number 3 to line number 2, here we select the last element as pivot with the value of integer, which is the p, using which array is partitioned. So here in which is called I, and its value, which is the low with -1, it shows the smaller element index. So here at we are using a for loop statement with if. So here at the if statement, we are checking if the current element is less than or equal to p. So here at the inside of our if statement, we have this to swap our int array and int So here at our if statement, we have here the swap our int array I and int array j. So here at int temp equals int array I plus 1, int array I plus 1 equals int array high. So we have to swap int array I plus 1 and int array high or p. So we have here the return I plus 1. So we have here our void quick underscore sort. So int array, int low, int high, we have here our arrays. So it is the routine to sort the array partitions recursively. So if low less than high, so is low is so they're asking if is low less than high. So in int p equals partition int array low high, it is our array. So partition the array around p equal to greater than partitioning index and return p. So quick underscore sort int array low p -1. So we have our value of quick sort, which is the arrays. So sort each partition recursively.
Class main. Public static void main string args. Initialize a numeric array. Int array is equal to 4, -1, 6, 7, 0, 5, and -3. Int in is equal to int array dot length. Print the original array. System out print line original array plus arrays to strings int array. Call quicksort routine using quicksort object. Quicksort object is equal to new quicksort. Object dot quicksort int array 0 and -1. Print the sorted array. System out print and sorted array plus arrays to string int array.